Welcome to Sage Audio. Today we're talking about how to compress vocals. But first, if you have a mix that you need mastered, send it to us at sageaudio.com to receive a free mastered sample of it. Basics of compression. Real quick, let's cover some of the compression basics. Your ratio is the input to output relationship. So 2:1 means that for every 2 dB of input, you'll get 1 dB of output. This relationship begins once the signal crosses the threshold. How quickly this compression begins after the signal crosses the threshold is the attack time. Once the signal falls back below the threshold, the release time determines how long for which compression continues. Lastly, the range will be the total amount of compression that can occur. So if I set it to 5 dB, I can only ever achieve 5 dB of attenuation. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Soft versus hard knee. When compressing your vocal, you'll want to decide on either a hard knee or soft knee setting. A soft knee results in more gradual compression that becomes more aggressive the louder the signal. Hard knee is more like an on or off switch for the compression. Soft knee settings have a more classic sound, somewhat like analog equipment. Hard knee settings sound more modern and aggressive. Let's take a listen to the two.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Attack and release settings. When compressing vocals, the attack and release settings do a lot to the timbre of the vocal. For example, a long attack will cause less compression while letting transients pass through unaffected. A short release causes the level to go back to normal quicker, causing retention to details. For vocals, I like to use a quick attack and moderate release. This lets me capture the majority of the vocal while retaining some detail due to the release time. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Internal sidechain. If you want a certain aspect of your vocal to cut through your compression, use the internal sidechain to attenuate that part of the signal. Granted, this frequency will still be compressed when attenuation occurs, but it no longer will be able to trigger the compression. So say I want the vocal's high frequencies to be a bit more present. I can use a low-pass internal sidechain filter to accomplish this. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
External sidechained mix. You can use an external sidechain to trigger your vocal's compression, meaning a different signal from an external source is read by the compressor. When it comes to vocals, I can place a compressor on a source that's competing with the vocal, like the mix bus. Then, I'll use the vocal as the external sidechain, in turn, compressing the bus whenever the vocal is present, causing it to cut through. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Saturation versus compression. When compressing your vocal, you may be trying to decide between saturation or compression. Saturation is soft knee compression combined with harmonic distortion, whereas compression is just compression. Saturation results in a fuller, slightly louder sound due to the harmonics, but compression gives you more compression options. Try both to see which one sounds better on your vocals, and also combine the two to find a good balance between them. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Crisp parallel compression. If you want your compression to result in a crisp sounding vocal, you'll need to use parallel compression on the high frequencies. To do this, set up a bus or accent. On the auxiliary track, attenuate up to 5 kHz with a high-pass filter. Then heavily compress the signal. Use the auxiliary channel's fader to blend this heavily compressed high-frequency range back in with the original vocal. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Thick mid vocal. The same concept used for creating a crisp vocal can be used to make a full mid-range. In this case, use both a high and low pass filter to isolate the mid-range and then compress heavily. Again, blend this compressed signal back in with the original vocal. I like to use optical compression for this since I find that it blends the signal in a really pleasant way. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
Vocal rider, then compression. If you want a lot of control over your vocals dynamics, but you don't want to resort to aggressive compression, combine a vocal rider with compression. The vocal rider more or less automates the level of the vocal within a fixed range, controlling the dynamics without affecting the vocal's peaks. Then, the compressor compresses the already controlled signal, resulting in less of a need to aggressively compress. Let's take a listen.
Why did you leave me alone? Why did you leave me lonely? Why did you leave me alone? Why did you leave me lonely?
If you have a mix that you need mastered, send it to us at sageaudio.com to receive a free mastered sample of it. Also, join and become a member for exclusive videos and content. Thank you so much for watching.